Good morning. Today we're learning about triangles. I'm not going to do any big problems with triangles. We're just going to talk about some of the definitions. This sheet that you see right now is in your Google Classroom, and it is just there as a reference for you. With triangles, we have some terminology that we're going to review. One is the median. The median is a segment containing the vertex of the triangle to the midpoint of the opposite side. One of the big aspects that you need to see, it's the midpoint of the opposite side. So these two lengths are going to be equal. If this is 4, this one's going to be 4. If this is 27, this one will be 27. Okay? The centroid, the point of intersection of the medians, okay, of the three sides of the triangle is the centroid of that triangle. It will always lie inside the triangle. So I'm taking the medians, all three of the medians, and the centroid is what is on the inside of those. One of the big things that you're going to need to know, not for today's exercises, but for your portfolio, is this part down here. The centroid divides each median into two segments. The segments joining the centroid to its vertex is twice the length of the line joining the segment to the midpoint of the opposite side. So between the vertex and the centroid will be twice the length of the centroid to this median right here. So let's say the length between the vertex and the centroid right here, let's say that is 4. Then this one would be 2. Okay? If between the vertex and the centroid, if this was 6 units, then from the centroid to the median would be 3, half of that. And the whole thing then, 3 and 6 would be 9. Okay? The incenter, the point of intersection of the angle bisectors. If this is an angle bisector, then what it means is where this cuts it in half, both of these angles are going to be the exact same. The point of intersection of the angle bisectors of the three angles of the triangle is the incenter of that triangle. It is the point from where the circle is inscribed in the triangle. The radius is found by drawing the perpendicular from the incenter to any of the sides of the triangle. Once I get this incenter, okay, I'm cutting these angles, bisecting these angles, and I get this incenter, I can make a perfect circle inside the triangle. And between the incenter, or the center now of the circle, and that tangent line, which we have learned earlier in the week, that will be perpendicular. Okay? The circumcenter is the point of intersection of the perpendicular bisector of the three vertices. Okay? Now, we are going to do the perpendicular bisector of the vertices of the triangle. It's called the circumcenter of that triangle. It is not always inside the triangle. It could be outside the triangle for an obtuse triangle. And it would fall in the midpoint of the hypotenuse of the right angle triangle. The circumcenter is equidistant from the vertices of the triangle. So what this is saying is from the vertices of all these triangles, it is going to be the exact same from these vertices in here. If I were to take a circle and draw all around, perfectly around the three vertices of the triangle, the circumcenter would be the center of that circle. Now, this cuts these in half, but it's also perpendicular. So it's also 90 degrees at this point. And one last definition, the point of intersection is the orthocenter. The point of intersection of the altitudes of the triangle is the orthocenter of that triangle. Like the circumcenter, it falls outside the triangle in case of an obtuse triangle. Okay? So we're going from the vertex over here, and we're going to make a right angle. It is going to make the right angle with the other side. Okay? And here it is. That is called the orthocenter. I hope this helps. You have the exercises to do. They're very easy, these exercises on the back. I don't think you're going to have any problems with those at all. But if you do, I'm here between 10 and 11 and 1 and 2. Have a great day.